All right, so today we're going to be covering chapter 3 on sensation and perception. I think this is a really fun chapter and one that most people really get into because the topics are pretty relatable. These are things you experience in your everyday life on a daily basis. We all have senses, they're basically what allow us to interact with and experience the environment around us. My kids and husband and I usually play some sort of game over family dinner. And the other night, we were playing the game called Would You Rather, where you say, Would you rather do this or would you rather do that? And you sort of have to make a choice. And I asked, Would you rather lose your sense of hearing or lose your sense of taste? And it was just a fun, silly game, but it resulted in us actually having a great conversation about our senses and how they affect how we see the world and how we experience the world. And how, if we didn't have one of those senses, whether it be taste or sight or hearing, how we might see the world and interact with it differently. But I think that's how a lot of people think of the senses when we talk about them. We often think of them in the main five, right? So sight, hearing, smell, taste, or touch. But really, this is looking at the senses with a very narrow view. When in actuality, as humans, we have a much greater sense abilities than just these five. So, for example, you don't only feel touch, but you actually feel the pressure of a touch, maybe, or the temperature of something, the vibration or movement of something, pain, and so on. Hearing isn't only responsible for processing auditory stimuli, right? Sounds, but it's also responsible for maintaining your equilibrium and your balance. And we could really break down each of these five main senses into several different categories, demonstrating that our capabilities go far beyond just these five. And psychologists aim to study this broader view of sensation and how we process the information being brought into our brain through the senses. So, sensation is the process by which our organs receive information about our environment. So, this is the input part of the process. Whereas perception is the interpretation of this information. So the brain receives information from the sense organs and then sorts out and interprets that information so you can successfully interact with the environment around you. Now, a stimulus is just energy that produces some response in one of the sense organs. A stimulus can really be anything. It can be a bright light, it can be a hot stove, a cold wind, rain, someone calling your name, an alarm on your phone, and so on, right? So it can be any number of things in your environment. And stimuli can really vary in intensity, and different types of stimuli are going to activate different sense organs. So, for example, perhaps you feel the hot stove, right? This is the stimulus, it's heat, it's a temperature. And this type of sense is associated with touch. So, through the sensory organ of your skin, right? So, this information is brought to the brain, which processes and interprets this information, resulting in you pulling your hand away from the heat to prevent yourself from being burned. Or we could think about some chemical that's in the air. So let's say food is cooking, maybe you're making a lasagna, and as the cheese melts and the noodles start to bake, it releases a chemical component as that food is cooking that produces a specific scent, right? So the type of sense that is triggered is smell through the sense organ of your nose. This information, again, is then brought to the brain, which processes it and results in some behavior. Maybe your mouth waters if you're hungry, or it might result in you pulling out the lasagna out of the oven if it smells like it's done cooking. So you can see how the stimuli in your environment can vary between sounds, smells, touch, temperature, and so on. And they're all processed by your different sense organs. And when exactly is a stimulus strong enough for us to be able to detect it? How bright does the light have to be? How loud does the alarm have to be? How hot does the stove have to be? And to understand this, you first have to understand something called absolute threshold. So, this is the smallest or lowest intensity a stimulus can be at which you can still detect it. So, if the stimulus has less intensity than the absolute threshold, you won't sense it, right? So, it has to at least reach this level, but this is the lowest level it can be at where you can still detect it. Now, it isn't necessarily a finite level. Each stimulus is going to be slightly different, but as the intensity of the stimulus increases, so does the likelihood that you will detect it increase as well, which makes sense, right? As a stimulus becomes louder or as a stimulus becomes brighter or hotter, the more likely it is that you will respond to it. So, is there really a specific level of intensity it has to be? And the answer to that is no, it kind of varies. But psychologists have found that if the stimuli is detected at least 50% of the time at a certain intensity level, then that is considered to be the absolute threshold for that stimulus. Our sense organs as humans are actually really sensitive. So, like the book mentions, we can feel um, things like a bee's wing falling on your cheek, right, when it's dropped from a certain distance through your sense of touch. That's an extremely sensitive response. But we don't always respond to these really low intensity stimuli because we're never only processing that stimulus in isolation. We're never processing just one stimulus at a time. Because of other noise, quote unquote, noise in our environment, we can't always detect stimulation that well. So, noise is the background stimulation that interferes with our ability to sense and perceive other stimuli. Now, the reason I say quote unquote or do quotation marks around noise is because it doesn't just refer to auditory stimulus in this case. We're talking about it can be any type of stimulus. So, for example, perhaps your nose is sensitive enough to detect the smell of rosemary when you're only smelling that herb and nothing else. So, if we place that scent in isolation, you can't smell anything else, you're only smelling rosemary, you can detect that scent, right? However, when it's cooking in a dish, so let's say you're making like a beef dish with onion and carrots and potatoes, maybe there's some red wine in there, and so on and so forth with all your ingredients. Now, the specific smell of rosemary is actually really hard to detect because of all the other noise of additional smells or stimuli that are in the air that you're also trying to detect. So, see how in isolation we can detect certain things, but because of all the other stimuli that's in our environment that we're trying to detect, which we refer to as noise, sometimes you're not able to detect those lower intensity stimuli. Additionally, as you are exposed to a stimulus for a longer period of time, you become less sensitive to it. So, for example, the first time you hear a really loud noise, you might react quite strongly to it. You might startle or jerk away from the noise or wake up, right? If it's a loud alarm clock. However, as that noise continues, you pay less attention to it. So, this is why we often hit the snooze button on your alarm clock without fully waking up. Once you're used to a certain noise, you no longer pay attention to it. And people ask, well, then how do I attend to my alarm for my wake up alarm? You have to actually change the ringtone or whatever sound it is that you're waking up to, because now it's going to be a novel or a new sound that you're not used to. right? Once you start getting adapted to or used to that sound, you won't attend to it as well. You'll push the snooze button, maybe without even really waking up. You'll sleep right through your alarm. So that's adaptation. All right. So now that we have a basic understanding of how sensation works and how we perceive those sensations, let's get into each of the senses. So, first, we're going to be talking about vision. Now, we could have an entire unit talking only about one of the senses. But since we're covering them all, each one is just going to be covered briefly, and I'm just going to give you the overall basics of how these work. If you were to take a biology or an anatomy class or even a chemistry class, you would talk about some of these things in much greater detail. So, first off, with vision, we're going to start with vision. Vision starts with light. Light is just a form of electromagnetic radiation waves. It's the physical energy that comes off of those waves that stimulates the sense organ of the eyes. So, everything we're able to see is actually a reflection of these light waves. So, light is measured in wavelengths, which is the distance from the peak of one light wave to the next peak of the next light wave. We refer to the visual spectrum when talking about the range of wavelengths that the human eye is able to detect. So, this spectrum includes the colors of the rainbow, ranging from the shorter wavelengths that give off a violet blue color to the longer wavelengths that give off a red color. So typically humans can respond to wavelengths between 390 to 700 nanometers, which is actually pretty restricted in terms of the wavelengths and what we're able to detect. So when I show you the visual spectrum in a moment, you'll see how small that is in relation to all of the light waves that are present in our environment. But other species, so such as birds and reptiles, they're actually able to see a larger spectrum, typically including the ultraviolet rays, which cannot be detected by the human eye. Light, of course, is processed through the sense organ of our eyes. We're going to talk about this in detail, but the incoming light is converted to a form that can be used by the neurons taking messages to the brain. So this allows the brain to process the incoming information. So here is a light spectrum, and you can see that the visual spectrum is actually just a really small portion that falls between the ultraviolet rays and the infrared rays. So it's sort of taken out and blown up so you can see it bigger. But if you look at that upper box, it's showing you that the visual spectrum is actually very, very small. So it's this small spectrum that ranges from violet blue to red that we are able to detect with the human eye.